Relative basic strength of aromatic amine. Tell me. Can you tell me example for aromatic amine? Aniline, right? Okay. Aniline. Tell me. So what is the basic strength of aniline? So we know that basic strength of not only aniline, all bases, basic strength of aniline is directly proportional to electron releasing group. What are electron releasing group? Plus I group, comma, plus M group, hyper conjugation, inversely proportional to electron withdrawing group, minus I, comma, minus M group. Okay, it means basic strength of aniline is increases when there is a plus I, plus M hyper conjugation groups are present, decreases when there is a minus I, minus M group present. Okay. Next, can you tell me among aliphatic and aromatic and amine, that is ammonia, which is more basic? First point is you compare the basic strength of ammonia and aromatic amine, which is more basic. So ammonia is more basic compared to aromatic amine, that is aniline. Why? Ammonia is more basic than aniline. Tell me why the ammonia is more basic? Because in ammonia there is a nitrogen there is a lone pair on nitrogen. Even in aniline there is a one lone pair on nitrogen, right? Both are having one lone pair each. And first difference is in ammonia this is a lone pair which is localized lone pair, as well as in ammonia nitrogen undergo which hybridization? sp3. Next difference is this is a delocalized lone pair, and what is hybridization of this nitrogen? sp2. So therefore now which is more basic? Ammonia is more basic compared to aniline. Yes or no? Because sp2 nitrogen has more electronegativity compared to sp3 nitrogen. Yes or no? Therefore ammonia is more basic than aniline. Next, when you compare aromatic amine and aliphatic amine, which are more basic? Aliphatic amines are more basic than aromatic amine. Next point, aliphatic amines are more basic than aromatic amine. Tell me, for example, let us take alkyl amine and aniline. So among alkyl amine and aniline, which is more basic? Alkyl amine is more basic, because in alkyl amine alkyl group is a plus I group. Now here is a minus I group, as well as another difference is this is a delocalized lone pair, and what is hybridization? sp2. Now what about this? They are localized lone pair, sp3. Okay, to compare the basic strength, first thing, you have to compare lone pair, whether delocalized or localized, and you need to compare hybridization also. Okay, whether hybridization sp2, sp or sp3. Okay, so therefore aliphatic amines are more basic compared to aromatic amines. Next, one more example. Let us take methyl amine, comma, ammonia, comma, aniline. Tell me, which is more basic? So methyl amine is more basic. Why? It is a plus I effect, this is a minus I, as well as lone pair. Say here lone pairs are, both the case lone pairs are localized, it is also localized. but here in this case delocalized. And hybridization sp3 sp3, this is sp2. So therefore aliphatic amines more basic, then ammonia, then next is aromatic amine. Okay, next then let us say ortho effect. Come on, tell me what is ortho effect. So we have studied ortho effect even in carboxylic acid, that is aromatic carboxylic acid. So what is the ortho effect in aromatic carboxylic acid? Aromatic carboxylic acids are ortho substituted aromatic carboxylic acids are more acidic compared to benzoic acid, that is aromatic carboxylic acid. It means if any group present, it may be electron releasing or electron withdrawing. So if electron withdrawing or electron releasing group present at ortho position in benzoic acid, that benzoic acid is more and more acidic, right? It means acidic strength of benzoic acid is increases due to ortho effect. When acidic strength increases, what happens? Basic strength decreases. The same thing happen here. Then what is ortho effect in case of aniline? Ortho substituted aniline is less basic than aniline irrespective nature of substituent. It is called ortho effect. Say it is opposite. Due to ortho effect, benzoic acid acidic strength increases. Due to ortho effect, aniline basic strength is decreases. So therefore, yes or no? So therefore here ortho substituted aniline is less basic than aniline irrespective nature of substituent, right? So ortho substituted aniline is less basic than aniline irrespective nature of substituent, called ortho effect. So therefore now let us see example. Let us take aniline and orthonitro-aniline. Tell me which is more basic. So here in order to compare the basic strength, acidic strength, we need to check this group operate or this group exert which effect. 1 minus I will be there, 2 minus M will be there, and ortho effect also there. Now tell me, minus I minus M both decreases basic strength, ortho effect also decreases basic strength. So therefore remember, ortho effect is much more compared to remaining two effects. So therefore which is more basic? Aniline is more basic compared to orthomethyl aniline. Next, one more. Let us take aniline, orthomethyl aniline, metamethyl aniline, paramethyl aniline. Tell me now what is the order of basic strength? 1, 2, 3, 4. Tell me what is the order of Kb, basic strength. So which is more basic? So therefore write the what effects possible. 1 plus I, 2 hyperconjugation. So remember, when alkyl group, this is alkyl group having at least one hydrogen, alpha hydrogen, can exert hyperconjugation. Therefore here methyl group has 3 hydrogen, 3 hyperconjugation is possible here. So therefore hyperconjugation possible, and moreover hyperconjugation operate from which position? Ortho and para. It do not operate from meta. Therefore here tell me, plus I operate from all the positions. Here hyperconjugation is there? No. Next, 4, tell me, plus I hyperconjugation, because para position, from the para position all, that means hyperconjugation will be there. Tell me now which is more basic. See, in first case there is no any electron releasing. Methyl group is electron releasing because of two effects, and there is a ortho effect. So therefore, if there is a ortho effect is much more. That means it is the least basic. So therefore, second is very least. Okay. Then after second, which is least? 1 is least, because there is no electron releasing. Now tell me, among third and fourth, which is more basic? In third case, electron releasing because of plus A effect. In fourth case, electron releasing because of plus A hyperconjugation. Therefore, this is more. Then you may have doubt. Plus A effect meta position here is more. Plus A effect para position less, no? But which is dominant? Hyperconjugation dominant. That's what. So due to hyperconjugation, it releases more electron. It releases electron more compared to this meta. That's what. Now tell me, among 3 and 4, which is more basic? So fourth one is more basic than 3, then 1, 2. Do you understand? Next. Next, one more example. Me is methyl, ortho-methyl aniline, ortho-nitro-aniline. Tell me, which is more basic? So here methyl group is plus I, hyperconjugation, ortho effect. Here minus I, minus M, ortho effect. Right. Then tell me, which is more? Now here all are electron withdrawing, right? All are electron withdrawing groups only. All decreases basic strength, but here these two effect increases basic strength. That's what. First one is more basic compared to second one. Right. Next. Tell me, so what is the order of basic strength? So which is more basic? Aniline. So here tell me, NO2 group minus I minus M ortho effect. Here minus I, that's it. Next here minus I minus M. We know that minus I minus M both are electron withdrawing effects. Ortho effect also electron withdrawing effect. So due to all three effect, basic strength is decreases. Therefore, which is comparatively more basic? 1. So therefore 1 is more basic. The next is no, second is least basic. Yes or no? Compared to all, second is least, very least basic. Therefore you leave about this. And among 3 and 4, which is less basic? Fourth is less basic because there are two effects. So therefore fourth one, the next, third one, next is first third. No, 1 then 3. More basic, no, 3 then 4 then 2. Okay. So 1, 3, 4, 2 order of basic strength. Okay, next one more. This question already I have given once. Aniline, comma, pyridine, comma, pyrrole, comma, cyclohexanamine. What is the order of basic strength? Okay, so to answer this, first of all you need to remember basic strength, that is Kb, is inversely proportional to electronegativity of nitrogen atom. So already written, yes or no? And electronegativity directly proportional to percentage of S character, this is also written. Tell me, so based on this information you can identify the basic strength. So therefore, to identify the basic strength, first thing is you need to identify whether lone pair electrons are delocalized or localized. Tell me quickly, this is what? Delocalized lone pair. Okay, here is, this is localized lone pair. Here is delocalized lone pair. Here localized lone pair. Okay, then now tell me, we know that when there is a localized lone pair, obviously more basic compared to delocalized. Therefore, which are more basic? Localized, no, B and D. So B and D are more basic compared to what? A and C. Okay, next see the among B and D, what is hybridization? Now tell me quickly, this is sp2, it is sp2, this is sp2 only, this is sp3. Okay, now we have decided that B and D are more basic compared to remaining all. Now among B and D, which is more basic? This is sp3 nitrogen, sp2 nitrogen. So sp3 nitrogen is more basic compared to sp2 nitrogen because En is inversely proportional to Kb. So therefore, which is more basic? D is more basic. Next, obviously B, because delocalized. Now there are two delocalized. This is a delocalized, this is a delocalized. Now among these two, which is more basic? A is more basic compared to B, because even though both are sp2, even though both are delocalized, but you need to see that due to delocalization it gets aromaticity. So therefore it gets aromaticity due to delocalization. Therefore these electrons must involved in aromaticity. They never try to donate it. If it try to donate, it lose aromaticity, it become anti-aromatic, that is unstable, almost does not exist. That's what this nitrogen not able to donate. There is a lone pair but not able to donate, it cannot donate. But here is not like this. Here condition is what? It is already there is a aromaticity, its aromatic ring is there. So due to conjugation it involved resonance, but due to resonance it do not lose aromaticity. See, for example, if this lone pair comes here, this pi electron comes here, no? Now where aromaticity loses here? 2, 4, 6. This ring has 6 electrons. Therefore, due to conjugation, lone pair involved resonance, but due to resonance it does not lose aromaticity. But due to resonance it loses aromaticity. That's what, it cannot lose electron, it cannot donate electron. So therefore, A can donate, but B never, C never. So therefore C is least basic. Okay, so E concept, based on this concept question can be framed many unlimited questions ನಾವು ಫ್ರೇಮ್ ಮಾಡ್ಬೋದು. ಈ ಥರ ಒಂದು JEE ಅಲ್ಲಿ 2017 ಮೋಸ್ಟ್ಲಿ ಆಗಿರ್ಬೋದು, 17 or 18 in JW there was one question asked. Question is given like this. I think same question we discussed ಮಾಡಿದ್ವಲ್ಲ. ಈ ಥರ ಒಂದು A B C ಅಂತ ಕೇಳಿದರೆ, ವಿಚ್ ಆಫ್ ದ ಫಾಲೋಯಿಂಗ್ ಈಸ್ ಮೋರ್ ಬೇಸಿಕ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಟೆಲ್ ಮಿ. No, which is more basic? Huh? A na B na? Again you are confused. See, this is a pyridine, no? Pyridine ring is always more basic because there is a localized. There is a one second, something wrong. ಈ ಥರ ಬರುತ್ತೆ ಅಲ್ಲ, ಈ ಥರ ಬರುತ್ತೆ. This comes like this. Okay. Now tell me. Now here, this lone pair is localized. Okay. Now this lone pair delocalized. This lone pair delocalized. More basic is B. After B, A. Least is C. Okay. Next. There was one more question appeared in CET. Question is like this. I think this is also we discussed. One second, take it. Tell me, which of the following is more basic? A, then B, then C. That's it. So therefore, if the question comes on basic strength, you see only two factors. One, lone pair, either localized or delocalized. Two, hybridization. ಎರಡು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಯು ವಿಲ್ ಗೆಟ್ ಅಕ್ಯುರೇಟ್ ಆನ್ಸರ್. ಇದಕ್ಕೂ ಜಾಸ್ತಿ ಏನಿರಲ್ಲ ಇದರಲ್ಲಿ ಅಷ್ಟೇ. ಸೊ ದಿಸ್ ಈಸ್ ಹೌ ಮೀಸೋಮೆರಿಕ್ ಎಫೆಕ್ಟ್ ಆ್ಯಂಡ್ ಇಟ್ಸ್ ಅಪ್ಲಿಕೇಶನ್. ನೆಕ್ಸ್ಟ್ ಈಸ್, ಏನೋ ಬೇರೆ ಇದೆಯಾ ಅಪ್ಲಿಕೇಶನ್ ಇದೆಯಾ? ಎನಿ ಅದರ್ ಅಪ್ಲಿಕೇಶನ್ ಇಸ್ ದೇರ್? In mesomeric effect, this is the last application, no? Okay. So next is hyperconjugation. Hyperconjugation. It is also called no bond resonance. It is also called Baker-Norton effect. Baker-Norton effect. Okay, so what is it is a last electronic effect. What is hyperconjugation, no bond resonance and Baker-Norton effect? Say the application of hyperconjugation directly, indirectly, almost we have completed. Okay, tell me, hyperconjugation, whether it is electron releasing effect, electron withdrawing effect. Finished. It is electron releasing effect. Then hyperconjugation operate from whether ortho, meta, para position. Which position? Ortho and para. It do not operate from meta position. Okay, that's what we have studied. Almost 90% things, related concept, everything. We need to know only definition. What is the definition? And we have to identify which following molecule can exhibit hyperconjugation, cannot exhibit hyperconjugation. Only that is left. Okay, fine. So what is hyperconjugation? To understand hyperconjugation, you need to understand where this is possible. I'll take simple molecule carbocation. We have studied. Let us take, it is a carbocation. Adjacent to carbocation there is a carbon. It is, let us take sp3 carbon only. sp3 carbon. This sp3 carbon is called what? Alpha carbon. This alpha carbon has hydrogen 1 2 3 3 alpha hydrogen, and we know that it is a carbocation. This carbocation undergo which hybridization? sp2 hybridization. This is also we know, and it has one vacant p orbital. Yes or no? We have studied that if carbon undergo sp2 hybridization, there is a one p orbital. That p orbital is perpendicular to plane. Okay, but perpendicular to the plane which has one free electron, unpaired electron, but it is carbocation. Since it is a carbocation, there was one unpaired electron that is lost. Therefore, in carbocation there is no unpaired electron. It is actually empty. So this is what? Empty p orbital. Now what is hyperconjugation? Hyperconjugation nothing but it is actually delocalization. The delocalization of sigma electron. See, these are the sigma electron. These sigma electrons are delocalization takes place in between what? Carbon and this empty p orbital. So that what happens here? It gives a new structure where hydrogen will be left here like H. It is not H plus. No, it become H plus. No, it become H plus here. Now complete bond shifted here, and this bond comes here, and CH become it is C. So actually it should be CH2 should be there. It is CH2. Now this is takes place because of hyperconjugation. Tell me, in hyperconjugation, what is happening here? You need to understand. There is a delocalization. The delocalization of which electron? Sigma electron or sigma bond. Sigma electrons of what? sp3 CH bond. It is sp3 CH bond with empty p orbital of adjacent carbon, called hyperconjugation. That means there is a overlapping of empty p orbital of carbocation and sigma bond of what? Adjacent CH bond. They overlap. Due to overlapping, they form one new pi bond. That is because of this phenomena called hyperconjugation. Okay. So therefore, in hyperconjugation, what happens? Isto nimpidir sak. Mechanism that is secondary. So what happens here? There is a overlapping of sigma electrons of sp3 CH bond with empty orbitals of adjacent. It may be carbocation, it may be free radical, it may be even alkene also. So this is takes place. Now due to hyperconjugation, you will get like this structure. This is 1, you will get 2, you will get 3. So you will get another 2 structures. This is 1, 2, 3 structures. So therefore, in hyperconjugation, there is a bond is here. This bond completely shifted this side. That's what here there is no bond, but H plus is there. H plus never shifted this side, that side. It doesn't go anywhere. It will be left there itself. That's what it is called a no bond resonance. Okay, it look like resonance, but bond will be not there. But it is not called actually resonance. In resonance, what happens? Is there any breaking of bond, making of bond is possible? No. There is no sigma bond breaking, making possible. But it look like resonance, but bond is left. Bond is broken, bond is shifted. That's what it is called no bond resonance. And it was observed by Baker and Nathan. Hence it is called Baker-Nathan effect. This is hyperconjugation. Next, characteristics. So what are the characteristics of hyperconjugation? First, write the definition. What is the definition of hyperconjugation? Displacement of sigma electrons of sp3 CH bond. Yes or no? No, whatever we did here, that already. Displacement of sigma electrons of sp3 CH bond with what? With empty p orbital, no? With empty p orbital of adjacent carbon atom. So empty p orbital of adjacent carbon atom called hyperconjugation. Okay, so you can take general example. carbocation. This is a empty p orbital. Next is characteristics of hyperconjugation. 1. So what are the characteristics of hyperconjugation? Tell me first, where the hyperconjugation possible? There are 3 molecules. 1 carbocation, free radical, alkene. Carbocation, free radical, alkene having at least one alpha hydrogen can exhibit hyperconjugation. Next, second characteristic. Hyperconjugation is possible or operate from which position? Ortho and para. It do not operate from meta. So therefore, these two are the important characteristics. 1. Carbocation, comma, free radical and alkenes. Carbocation, free radical and alkenes having at least one alpha hydrogen. One alpha hydrogen on sp3 carbon can exhibit hyperconjugation. No, it must be sp3. Again, it should not sp2 like sp. Alpha hydrogen must be on sp3 carbon, then only it is possible. Can exhibit hyperconjugation. Next, second characteristic, it operate from ortho and para position. It means it depends on distance or position. Position. Therefore, it is called positional effect. Which of the following is not a positional effect? Which of the following is a distance effect? So this is a positional. So therefore, it does not depends on distance, but depends on position. So it depends on position, that is it operates from which position? Ortho and para positions. So it operate from ortho and para position. It do not operate from meta position, right? Okay. Then now let us see example. I'll take same example, carbocation. This carbocation CH2 plus. Okay, tell me, write the hyperconjugation for this. For hyperconjugation, there is a carbocation adjacent to carbocation alpha carbon. This alpha carbon has 3 alpha hydrogen. Therefore, these 3 alpha hydrogen involved hyperconjugation. Therefore, to write hyperconjugation structure, you should not change the position of hydrogen. Remaining 2 hydrogen write as it is. 1 become H plus. Why? This bond completely shifting here, and moreover this become actually it was positive, it become neutral. Therefore, double bond comes here. This is one. Next, tell me another one is, now shift this hydrogen here, it become this. Positive charge come here, HH will be same, then double bond CH2. Another hyperconjugation. Will you get another? No. No, same as first one will get. Okay. Then tell me now. Now total number of structures how many? It 1, 2, 3. And this is also 1, no? So therefore 4. So that's what number of hyperconjugation is equals to number of alpha hydrogen plus 1. Yes or no? Because here 1, 2, 3, there are 3 alpha hydrogen. How many hyperconjugation? 3 plus 1. You will get the 3 structures plus original structure. 3 plus 1. So in this way you can calculate the number of hyperconjugation. Here questions are like this. Most of the time they ask question, which of the following exhibit or do not exhibit hyperconjugation. It's most commonly asking question. If not this, how many hyperconjugation? Right, which of the following molecule exhibit 3, 4, 5, 9? How many hyperconjugation 10 are possible for so and so molecule? Only these 2 questions. And there are 2 applications. On application there are some more questions. Okay, so we will do that only. Right, like question only. Calculate the number of hyperconjugation in the following. Write the question. Calculate the number of hyperconjugation in following. Okay. 1 CH3 CH2 plus 2 CH3 CH plus CH3 3 CH3 CH3 Fourth one and second and fourth same. Second, fourth same. How become same, man? Hydrogen 1, hydrogen 2, hydrogen 3. Now tell me. There are 3 hydrogen, no? Same alla. Tell me. So calculate the number of hyperconjugations in molecule. If any molecule exhibit 0 means no hyperconjugation, that is a 0, that is not possible to exhibit hyperconjugation. Tell me. First one, see, this is carbocation, right? Adjacent to carbocation, this carbon is called alpha carbon. On alpha carbon there are 3 alpha hydrogen. Therefore number of hyperconjugation 3 plus 1 4, because you will get 3 hyperconjugation plus 1 more original structure. Total structures are 4. Next, here there are 2 alpha carbon, 6 alpha hydrogen. So 6 plus 1 7 hyperconjugation. Next, 10 hyperconjugation. Next, so 3 plus 2 5 6 hyperconjugation. Next, 1 hyperconjugation 0. No, whether this exhibit hyperconjugation? No. See, if it comes to no, can it exhibit hyperconjugation? No. Why? There is no alpha hydrogen. If there is no alpha hydrogen, total structure 1 only. Now this is we have written total number of structures including hyperconjugation, but it do not exhibit, right? So do not exhibit hyperconjugation. So question is like this: which can exhibit, which cannot exhibit? It cannot exhibit. Next, here there is a CH3, right? How many? 4 hyperconjugations, 4 structures. Next here, so here hydrogen, here is CH3 5. Next here, and say like carbocation, free radical also sp2, no, sp2. Therefore the stability of carbocation free radical is similar with respect to this hyperconjugation. Here how many hyperconjugation? Again 4 possible. Next, 10 hyperconjugations. Next, so 3 plus, no, sorry, yeah, this is, 1 plus 3 4 5 hyperconjugations. Here, now tell me one more, like similar to carbocation free radical, alkene can also exhibit hyperconjugation. You see the condition. So to exhibit hyperconjugation, what is the condition? 1 carbon should be sp2, okay, adjacent carbon should be sp3 and having at least 1 alpha hydrogen, no? Yes or no? Then what happened? This hydrogen may overlap, sigma bond overlap with this, and of course this bond shifted here, that is secondary. Yes or no? Therefore hyperconjugation also possible with alkene having at least 1 alpha hydrogen. Possible tane? So how many? 4 hyperconjugation. Here 3 plus 3 6 plus 1 7. Here 3 6 7. Here 3 6 plus 1 7. Next, tell me here is 3 2 5 plus 1 6 hyperconjugations possible. Now tell me, if the benzene ring having any alkyl group can exhibit hyperconjugation or not? ಅಲ್ರಿ ಈ ಥರ ಬರೆದಾಗ ನೀವು ಹೇಳಿದಿರಲ್ಲ hyperconjugation ಅಂತ. Tell me what are the effect here? This methyl group plus idea. Next is plus methyl group plus em ಬರುತ್ತಾ? hyperconjugation ತಾನೆ. And ortho? Is it phenol comes ortho effect? Phenol is not. Okay. So therefore plus I will be there, methyl group, hyperconjugation. It means why hyperconjugation? Why we have written hyperconjugation? See, say compare the same condition. For hyperconjugation there should be sp2 carbon adjacent should be sp3 should be there, no? Now this is sp2 carbon, right? sp2 carbon attached to what? sp3 carbon, which is having 3 hydrogen. Same condition. So therefore, if the benzene ring containing any alkyl group, there is a possibility of hyperconjugation, because benzene ring carbon is sp2 carbon. If sp2 carbon attached to any sp3 carbon, possibility of hyperconjugation, but condition is what? There must be again alpha hydrogen should be there. Now tell me here, can it exhibit hyperconjugation? Yes, we have written application, we have written many. So therefore it exhibit hyperconjugation because there is a sp2 here, sp3, right? So therefore hyperconjugation possible. How many hyperconjugation? 3 plus 1, 4. Next here, how many? Only 2 hyperconjugation, because there is one alpha hydrogen. Okay, next. So is there any hyperconjugation? No, means nil, no hyperconjugation structures. Next here, CH3, 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 12 plus 1, 13 hyperconjugation structures possible. Next, nil, no hyperconjugation. Okay, say this question 16, 17, 18, this question was given in JEE. Question is this: among 16, 17, 18, which of the following is a more electron releasing group? Methyl, isopropyl, it is tertiary butyl. Methyl, tertiary butyl. Okay, one more point. Methyl, isopropyl, tertiary butyl, all are plus I effects, plus I group. It exert plus I, it exert plus I, it also exert plus I, exhibit plus I. Then what is order of plus I? We have studied. If the size of the alkyl group increases, plus I effect is increases. This is more plus I than this, than this. Methyl is a least plus I, tertiary butyl is a highest plus I. But when comes to hyperconjugation, methyl is a more hyperconjugation, tertiary butyl no hyperconjugation. Now question is, which of the following group is more electron releasing group? Either methyl or tertiary isopropyl or tertiary butyl. Methyl, because hyperconjugation dominate. Because in hyperconjugation what happened? Why dominate hyperconjugation? In hyperconjugation there is a complete, now what happening? There is a displacement of sigma electron, so that there is a moment of sigma electron takes place. Complete displacement is there. Have written in inductive effect there is a complete displacement? No, there is a partial displacement, right? It's complete displacement. Therefore hyperconjugation dominate inductive effect. That's what electron releasing, this is more than this, than this. Okay, so this is hyperconjugation and related concept. Next is applications of hyperconjugation. Right, quickly. Applications of hyperconjugation. One, applications of hyperconjugation. So there are 2 applications. Those 2 applications already we have studied, but once again we will let example. 1, stability of carbocation, comma, free radical, comma, alkene. So we can explain the stability of carbocation and stability of free radical, stability of even alkene based on hyperconjugation. 2, electron releasing power of alkyl group attached to the benzene ring. right? Electron releasing power of the alkyl group attached to the benzene ring. Just now we discussed. No, that is only that only. Okay. Now tell me, first one, stability of carbocation, stability of free radical, and stability of alkene. So what happened the stability of all these three with hyperconjugation? It means the stability of all three is directly proportional to hyperconjugation. As the hyperconjugation increases, stability increases. So therefore, stability of carbocation, free radical and alkene directly proportional to number of hyperconjugation. Number of hyperconjugation structures. As the number of hyperconjugation increases, stability increases. So already we have written in stability of carbocation and free radical, etc. Okay, once we'll write one more example. Come on, tell me. So what is the order of stability of this? Which is more? Secondary more. Why so? ನಾವು ಈ ಟಾಪಿಕ್ ಸ್ಟಾರ್ಟ್ ಆದಾಗಿಂದನ ಟೆರ್ಷಿಯರಿ ಮೂರು ಹೇಳ್ತೀವಲ್ಲ, ಮತ್ತು ಸೆಕೆಂಡ್ ರ್ಯಾಂಕ್ ಬಂತದು. ಹಾಂ, how? See, this is carbocation, alpha carbon, alpha carbon, alpha carbon. There are 3 alpha carbon, 9 alpha hydrogen. Therefore, total 10 hyperconjugation structures. Here, 6 plus 1, 7 hyperconjugation structures. Here, 3 plus 1, 4 hyperconjugation structure. Here, no hyperconjugation. Therefore, so 10 hyperconjugation more stable than this, than this. It is nothing but we have studied. So 3, 2, 1, no, 321 stability. So stability of carbocation 321, stability of carbanion is 123. Reverse tane. Okay. Next, one more example. Tell me. Now, which of the following carbocation most stable? First one. See, both are secondary. Both are secondary. Then you need to compare the hyperconjugation. There are 7 hyperconjugation structures. Here is 6 hyperconjugation structures. 7 is most stable. Okay, like that. Similarly, free radical alkene also. I'll write one example. Tell me quickly. Methyl radical, ethyl radical, isopropyl tertiary butyl. Tell me, which is most stable? Tertiary, then secondary, then primary, then methyl radical. That's what the stability of free radical exactly similar to stability of carbocation. But one there is a difference is one. Carbocation undergo rearrangement, free radicals do not. Right? See, among reaction intermediate, only carbocation undergo rearrangement, and many questions comes based on carbocation, and even 50% organic chemistry, there will be involvement of carbocation, direct indirectly irutte. So therefore, now this is free radical. Next is alkene. Even if you take alkene also, CH2 double bond CH2, CH3 CH, CH2, CH3, CH double bond, and one more is So what is the order of stability of alkenes? So try to identify how many hyperconjugation possible. As the number of hyperconjugation is more, stability will be relatively more. Tell me. So here how many hyperconjugation? Huh? 0, because there is sp2 carbon, sp2 carbon. For hyperconjugation, sp2 carbon should be attached to sp3 carbon. That carbon should have alpha hydrogen. Yes, therefore it is nil, no hyperconjugation. Here how many? 4 hyperconjugation. Here how many? It is a 3, 3, 3, 9, 9 plus 1, 10 hyperconjugation. Next here is 13 hyperconjugation. So therefore stability is increases. As the number of hyperconjugation increases, stability of alkene also increases. Comparison like that only. Okay. Next question is, one more question is like this. There is a alkene CH3H, CH3H, another alkene HH. Tell me which is more stable? First one. Why? 3 plus 3, 6. 6 plus 1, 7 hyperconjugation. There is no hyperconjugation. Next, one more. Which is more stable? So hyperconjugations, 3 plus 3, 6, 7 hyperconjugations, 3, 3, 7 hyperconjugation. So number of hyperconjugations are same, but one is a cis, another is trans. This is trans, this is cis. Which is more stable? Trans is more stable. Very good. We have studied in alkene where geometrical isomerism. So trans isomer is more stable compared to cis isomer. Right? So in this way you can compare the stability of alkene also. Then last one, electron releasing power of alkyl group attached to the benzene ring. Electron releasing power of the alkyl groups attached to the benzene ring. So this is the previous JE question. As this question was given like this. It is CH3 Okay, same example we have studied in carbocation also. Tell me now. So what is the order of stability? It is a carbocation, right? Now tell me, with respect to carbocation, can it has alpha hydrogen here? Note, this is carbocation. Is there any hydrogen like this here? Not, because, and one thing, it is actually sp2 carbon. This carbon sp2. And there is no hydrogen. That's what, with respect to carbocation, there is no hyperconjugation here. Not possible. But this methyl group can exhibit hyperconjugation. Yes or no? It can exhibit hyperconjugation. So why? Now with respect to this, it is sp2 carbon. Now this is sp3 carbon. Therefore sp3 carbon attached to sp2 carbon which is having at least one alpha hydrogen, it can exhibit. That is the condition. Therefore here possible, there are how many hyperconjugation? 3 plus 1, 4 hyperconjugation structures are possible. Here 3 hyperconjugation structure, here 2 hyperconjugation structures, here no hyperconjugation. Therefore now question is, now which of the following alkyl group is more electron releasing? Order of electron releasing, methyl group. When you consider inductive effect, this become more, right? But when you consider hyperconjugation, this become more. So therefore order of electron releasing effect. So what is the order of electron releasing effect? Methyl group is more than ethyl group, then propyl group, then tertiary butyl group. Okay. Now see, but in case of aliphatic carbocation, now this is aromatic. Now same question I will give aliphatic. For example, let us take CH3 CH2 plus, first take methyl, ethyl, tell me now. Now which carbocation is most stable? It is a primary carbocation, primary, all are primary only. All are primary carbocation, but which carbocation has more hyperconjugation? First one, right? Therefore first one is most stable, then second one, then third, then fourth. So it means if you consider inductive effect, this is more, it has highest plus I effect but no hyperconjugation. So hyperconjugation dominate inductive effect. Okay, so this is about electronic effects. Okay, so write the heading, types of organic reactions. Types of organic reactions.